Good evening. My name is Nate. So I'm going to be the MC tonight, and I can still see Owen stuff like walking around. It's pretty funny. So we are actually having this course at the JR Academy. So this course is actually designed to help those who actually want to get into the data analytics or business analytics industry or career. And then we're actually trying to help them to get them sort of like prepared with the right skills before they can sort of like start going to the real job. Normally for our students, they're either not in the data career or industry, try to move into that, or it's going to be the uni students graduated, because like there's still some gaps between like university education versus what would be the industry expectation. So that's normal. That's why so we are actually having this course, and through our courses we're actually teaching stuff like some of the programming language like SQL, like Python, like some of the data visualization like Tableau, and we're also taking them through some of the what it looks like as a real world sort of like projects. So as here we are today. So all our students are actually joining into a sort of like a group project, and they're trying to leverage what they have learned throughout the course to a few sort of like project, and then be able to show that tonight. So they're going to be 3 groups. So we're doing the showcase tonight, and I'll introduce them one by one. So before that, I'm going to give a bit of introduction to our guests here. So I believe we have about 5 guests tonight. So the first one is actually Si Ying. Si Ying is a postgrad student, postgrad of Master of Business Analytics from Melbourne Business School. She's currently working as a senior pricing analyst at Suncorp, the pricing and analytics team. So major projects she has worked on includes the designing some of the risk modeling and the demand modeling framework for the commercial products, and also applying various machine learning techniques to automate pricing process and improving pricing consistency and risk selection. And she's always passionate to combine modern data analytics approach and strong business acumen to help organizations make data-driven decisions. I'm not sure if you join in, you can probably wave and say hello. And the next guest we have is Isaac. Isaac is a manager in the data and analytics team at Deloitte within the financial advisory, turnaround, and the restructuring unit. So he's actually heavily involved in diverse strings of works, including like web application design, development and implementation, process automation, and data analytics. I can see Isaac, you just wave your hand. Yeah. The next guest we're having is actually Dr. Shen Liu, and he's actually a principal at LogicCube. So prior to joining the LogicCube, he was a data science manager at Woolies X, leading a team of about 20 data professionals. He designed the recruitment assessment framework for data scientists at Woolworths, and was instrumental in building one of the best and the largest data science teams in Australia. So he's also a qualified actuary and the lead author of a Big Data Analytics book, and the winner of the SoftBank Robot Award Competition 2017. Do we have Dr. Shen on the here? Yep. I can see someone waves. And I also have 2 guests, but sorry that I don't have their introduction. I might invite Jay and Stefan to give a bit of introduction for themselves. You might want to sort of like move towards my position, or you can just go to the stage to sort of like give a bit quick introduction of yourself. Hope that's okay. Yep. I'm sorry, Jay, on mute.
Hello, can everybody hear me now?
Yep.
Oh, perfect. Hey, hello everyone. My name is Jay. I'm working for Mobi. So Mobi is like it's like an ad tech platform, usually under the subsidiary of Singtel, the mother corporation of Optus. So my current position is I'm the director of the solutions and analytics of the business. So we build all these data analytics dashboards, custom reports, data automation for the clients, as well as internal sales and client services team. And I'm also involved in building new ad technology products in the industry for IAB, for Mobi, and for the clients. So thank you for having me here, and really looking forward to the session.
Hi, I'm Stefan. I also work for Mobi. I am a solutions analyst. I mainly work on the brand intelligence for reporting. We do different dashboards and brand lift type reports, which we send off to clients. I would also do some DSP work and slowly learning the analytics side of the scene. Hopefully things go well and this presentation goes great. Thanks, guys.
Cool, thank you. And thanks for joining our sessions tonight. And the next one on my agenda is actually to give a bit of agenda for tonight. So tonight we're having 3 teams to give their presentation. One is NOBUG, the other one is Dataemon, and the last team is actually QTF. So I believe they actually all joined. Each of the team will take about 15 minutes to present. And can I ask everyone to hold their question towards the end of their presentation? Probably their presentation takes about 10 minutes, and then we'll give each team about like 3 to 5 minutes to have this like a Q&A session. So the best way, I guess, to do is probably you can type on the chat box. You can probably see the chat box on your bottom right corner. Then you can actually type your questions through there. And once they complete their presentation, I can actually help you to sort of like read your question, and then the team can actually help answer them. So I think so that's roughly, each team will take about 15 minutes, altogether 45 minutes, and then that'll take us to 8 p.m. tonight. And once everyone's sort of like finished, every team finished, we'll open the floor to have a bit of like an open discussion. If you still have some like questions or things you want to do, then please feel free to to ask any questions or raise some interesting point if you like to. So that's probably the agenda for tonight. And so let's first invite our team, NOBUG team, to come to the stage, and I'll leave the call to you and to take us through your presentation. Welcome.
Where's Apple? Yeah, please come over here beside me. Stand beside me here.
Apple, can you see the sort of like reddish dot on the stage? If you come down a little bit, then probably that will be able to hear you present.
Move your character and stand beside me. Yeah.
Are you there, Apple? Or you can type in the chat.
Here.
Cool.
Sorry, Apple.
She just got lost.
Okay. Yeah, stand here. Yeah.
Okay.
Okay, thanks for waiting. Hello, everyone. It's my pleasure to present our project to you guys. I'm Stella, the leader of first group, the NOBUG team. The data set for our study is Queensland traffic accident data from 2001 and to 2021. Firstly, I would like to introduce the three main speakers, Stella, Apple, and Bill. There are three main parts to the project agenda here. First is data exploration analysis, modeling and forecast, insight analysis. And now we invite Apple to introduce her part.
Okay, hello everyone, I'm Apple. So our report will contain these three parts. Our team got a very big data set about Queensland traffic. It's not from customers who came to us waiting to find solutions. And it's not from coworkers who need us to monitor data performance regularly. Everyone in our team was thinking if there is any insight that matters to all of us. So this data has 6 tables. The major one, road crash locations, we simply call it table 1, where locations and the characteristics of crashes within Queensland. It contains all reported road traffic crashes from January 1st, 2001 to June 30, 2021. And other 5 tables provide different statistical dimensions with same time range. The only thing they have in common is crash year, a time variable. So this is a good starting point. Next page. We count the total number of crashes per year. 2021 has half-year data. That's why the value is just half of 2020, as shown in the red line. And we also know Queensland government stopped capturing property damage only for crash severity since 2011. This can explain the sharp decrease appears between 2010 and 2011. So after filtering them out in the green line, we can see 2020 is the lowest, 12,098. We also noticed that in Queensland, a road traffic crash which results in fatality and all person hospitalized is a serious crashes. So we counted serious and non-serious crashes by year. Next page. Yeah, in 2020, the difference between them is just 222. Then we convert to the serious ratio. It becomes a record high. 49%. Stella? Are you sure? Yes. It becomes, 49, you can see here, right? So these findings of 2020 are very counterintuitive. We all know what happened in this year. COVID appeared in Australia. The first case was diagnosed on January the 25th. Queensland began lockdown in April. Then we plot the monthly trend. Stella? Yes, in April 2020, these two indicators goes in the opposite directions. And after April, the serious ratio still kept in a very high level. So what should the data be like if there is no COVID? And let's invite Stella to talk about our models.
Thank you. I will introduce to the modeling process. In order to get a data curve that is not affected by COVID, our idea is to use historical data to build a model and then use 19 years of data to verify the error and accuracy of the model. Finally, use the model to predict the situation beyond 2020 so we can see the number of crashes without COVID. According to our idea, we first divided the data set into 3 parts according to the timeline. And the division was based on the time point when the first COVID case appeared. During the data exploration, we found that the data before 2011 was abnormal as a whole because the crash classification no longer reported property damage only. After 2010. Therefore, for the consistency of traffic data record, the relevant data before 2011 was removed. At the same time, we divided the remaining 4 categories into series and not series. Next, we have to diagnose the overall situation of the series. First, we decompose the data, and obviously we can see that the series has a seasonal component because the data produce a repeated pattern of 12-month frequency. In this case, the XiaoreJRMel model is more suitable for modeling because it adds a seasonal component to the XiaoreJRMel model. It better captures long-term patterns. The condition of time series modeling is that the series must be stationary. So we use ADF tests to test whether the series is stationary or not. If the series is not stationary, the difference, we can take a difference so we can obtain a stationary series. We can see that the original series is not stationary, but after the first difference, the series is stationary. So we can use it to the model. There are 7 parameters of XiaoreJRMel model. So we adopted a grid search approach to find them all. From our analysis just now, we can confirm 3 parameters, where the difference is 1 and the seasonality is 12. We can confirm the remaining 4 parameters by finding the model with the smallest AIC and BIC by grid research method. After computer calculation, we got the optimal model, XiaoreJRMel model here. And it has the lowest AIC, BIC is around minus 640. And its coefficient t-test also significant. However, for a good model, its residual should conform to the model assumption of normality, correlation, and randomness. Our model is really great, passing all tests at 95% significance level. At the same time, the model error and prediction error are very low, which means that the model can more accurately predict the data we need. Then let's take a look at the model fitting. There are 2 lowest values in the historical data. The first appeared between 2010 and 2011, when Queensland experienced once in 15 years flood. And the second was in 2020, when the government implemented a travel ban in order to control COVID spread. If we zoom in on the gray area, we can see a graph of the number of crashes predicted by a model without the impact of the epidemic. Here comes the point. We can see that the blue line, has dropped sharply after 2020, which is due to the traffic restriction in February and everyone home isolation, which caused the number of crashes to drop significantly to 641 after the restrictions were lifted in April. The number of crashes rebounded sharply to the level predicted, and the number was slightly more than previously predicted, reaching a maximum of 1,181. This may be due to the revenge travel psychology of residents, resulting in an increase in the number of traffic. Similarly, we feed the XiaoreJRMel model to the ratio of accident severity and predicted. Surprisingly, flooding did not affect the ratio of accident severity, but after travel bans were lifted in 2020, accident severity rose significantly from forecast. Let's zoom in. We see that after 2020, 2020 years, the February, the severity ratio dropped sharply to 0.4, rebounds to 0.53 after restrictions are lifted, and then repeats itself around 0.5, which is much higher than the model predicted. So why did the number of accidents increase and the severity of accident increase after travel restriction were lifted? So next, April will give up an insight analyst. April.
Okay, me again. Next page, please. Yeah. So now we all know if there is no COVID, this trend will be relatively stable. And let's have a look at two lowest crashes number in history. In January 2011, floods hit Queensland. The crashes number is the second lowest, but the serious ratio of the month meets our expectation. It changed with the trend of crashes number and lower than the January's. So what's the difference?
Sorry to interrupt, Apple. I think I cannot see your presenting. I'm just checking to see you can present or share your screen. Can anyone else see the screen except me? Or
I can see. Yeah, you can see. You can read.
Cool. Or otherwise, you can still talk through it while Stella is helping. Yeah.
Oh yeah. Sorry, because I moved.
Oh,
sorry.
No problem.
Okay?
Yeah. I can see
Yeah.
It's figured now. Yeah.
Sorry.
Okay. So where I can start? Yeah. So in the first graph, January 2011, floods hit Queensland. So the crashes number in the second is the second lowest, but the serious ratio of the month meets our expectation. It changed with the trend of crashes number and lower than other Januaries. So what's the difference between these external factors and why there are 5 supplementary tables provided in different dimensions? That's a hint. Let's think about, how COVID affect road crashes. Does it affect weather or road condition or traffic sign? We all know the answer. COVID has a huge effect on people, both health conditions and our way of life. So we extract data from table A to table E, calculate the average level between 2020 and compare it with 2020. Here we list items with notable changes. For drivers, drinking and overspeed increase. Fatigue and using defective vehicles decrease. After t-test, the first 3 items show a significant difference. Then we use the same method for other items. Next page. We can see younger drivers and elder drivers both have significant difference in 2020. What about casualties? Next page, Stella. Serious ratio of drivers has a significant increase in the same year. And next. 17 to 24 group and the 30th group display an abnormal growth in 2020. Remember the predicted line? If there is no COVID, the serious ratio should not that high. So let's focus on behavior indicator with significant increase. Next page. The three points are drinking driving, overspeed driving, and more younger drivers aged between 16 and 24. So let's imagine if we could replay 2020, what we can do to reduce serious crashes ratio. We have 3 advice. Next page. The first one, take measures to lower alcohol intake. And the second one, on social media, enhance driver safety awareness, target 16 to 24 group. And the last one, apply more temporary speed cameras and increasing speeding fines. Okay, my part is done. Bill will talk about the limitations and next steps.
Oh, sorry, Apple, you should move. Your character. Yeah. Thank you.
Can you guys hear me? Cool. Okay, so about my part. First of all, I created a feed-forward neural network model, which also aims to predict the time series data of the monthly crush. And the ultimate goal was the same as Stella's, and to make just to make a comparison between the two models. And eventually, my RMSE is 75, which is much higher than the XiaoreJRMel model. And so, just so we know that the XiaoreJRMel model is our best final prediction models. And after concluding our predictions about the time series data, I felt that there should be. Hold on. Can you move on to the, never mind. So after concluding our predictions about the time series data, I felt that there should be other features in the data which could help us predict the casualties in the future. This could provide significant values to the authorities such as roadside assistance for them to be better prepared to deal with the potential casualties. And the feature I selected are road surface conditions, road speed limit, and road lighting condition. I chose these features because they are environmental factors which has high coefficient with the casualties. And as a result of the model, it turns out that the 70-kilometer speed limit road, wet, sealed road, and the dawn dusk conditions are the three most significant features which affects the casualties. And this will be very valuable for the government officials or the relevant authorities to rely on when they to better prepare for the accidents. And about our limitations and the future steps, first of all, the insights is that the data captured at different levels of the granularity limits the information feeding into the model. And for the modeling, our model choices are limited to the XiaoreJRMel model and FNN and the logistic regression model, and which provides fewer comparisons. And for the forecast, the rolling forecast was not included, and the forecast was based on the historical in-sample data points only. So in the future, I think we should introduce more analytical tools for the model comparisons, and also to gather more sufficient data sets for our prediction model training. And that'll be the end of our presentation. Thank you.
Cool, thanks very much for Team NOBUG. I think from your analysis, what we can get, the insight we can get is that the lockdown not only saved our lives from the COVID, but also the car crashes. So I'm just trying to open the floor to see if anyone have any question for the team. I think you can either come near me or type your questions in the chat box. Or maybe you can come up to the stage. Anyone? I can see someone's moving. Yeah, we got a question. Could you please quickly explain, Jay actually asked, could you please quickly explain the difference between the XiaoreJRMel and XiaoreJRMel model?
Because the XiaoreJRMel model only fitted the normal series with trend only, but the XiaoreJRMel model can fit with the series with trend and also the seasonality. And after we composition the data, we can see we have a 12-month seasonality. So it's more reasonable to use XiaoreJRMel model. Yeah, it can capture the long-term pattern.
Cool.
Okay.
Chris,
Yeah, so sorry to interrupt. Actually, I have a general question for you guys. So could you do a brief introduction how your model work? Is there any basic methodology to support your model? And could you also explain why you choose this model? So maybe I can see there are a lot of different AI models. So could you give me a reason why you want to choose this model into your project?
Beg your pardon. So you mean why we choose XiaoreJRMel model as the prediction model?
Yes, thank you.
I think it's a very similar question like previous question. So it's mainly because we want to use the time series to feed the model and use the crash count series only. So we want to feed a REMA model at the first time, but we found that a REMA model get a huge error when we feed it. So we changed to XiaoreJRMel model because at the first time we didn't decompose the data, so we didn't find the seasonality. So after we find the seasonality, so we use XiaoreJRMel model. So this is the best model to capture the seasonality. Yeah. Thank you.
Yes, cool. Good presentation. And I also found you guys offer me some like background information. So like which kind of effects is mixed by the COVID or something. Yeah, I think that will be a really insight for me. Yeah, thanks for your group.
Thank you.
Yeah,
cool.
Bye.
Cool, thanks for the question and the answers, and also our team NOBUG. Just conscious time, probably let's move on to the next team. And at the end of today's showcase, you can still, if you're interested, you can still ask them any questions if you want. So let's invite the team Dataemon. So I think, yeah, please, team, you can actually now go to the stage and then try to prepare your presentation.
Yeah, can you move to that point next to me? No? Yeah. All right, can everyone see my screen or hear me?
Yeah.
Yeah, good. Okay, good evening, everyone. And today I'm really happy to share with you our project, the bank marketing campaign analysis. First of all, please allow me to introduce our team. And I'm Richard, and the team leader, and I'll also working doing marketing job now. And next is my teammate Yan. Yan, please introduce yourself.
Oh, hello everyone. I'm Yan. I just graduated from University of Tasmania.
Okay, and also Grace is our tutor for this project. Thank you, Grace. And now let's look at our project background. So the Portuguese background has been suffering a revenue decline. So they found that their client not deposit as frequently as before. So they want to identify the existing client that have which kinds of clients have are more likely to subscribe a term deposit. So in order to answer this business question, which we follow this analysis process,
from setting the business goals to model evaluation. And here we want to achieve two goals. And number one, we want to find the main characteristics of the client who are most likely to place a deposit. And number two, we want to create a classification model to predict whether the client will place a deposit. And now let's look at our data set. So our data set includes 5 categories. The first one is the bank client data information like their age, job, and marital status, and so on. And we also have some details related to the current and previous campaigns, like the contact type and the number of contacts during this campaign or in the previous campaign. And also we have some economic index that reflects the economic situation. And the last one is the most important variable. That's our desired target. And that's a binary variable. Yes means the client will place a deposit in the bank, and no means that the client will not place deposit. And before analysis, we need to do some data cleaning and pre-processing. So we find 5 problems we need to deal with. The first one is missing value. We drop or fill some unknown values in the data set based on the columns they are in. And we also find some duplicate values in the data set, and we drop the duplicate values. And the third one is outliers. And we draw some box plot and drop the outliers. And the fourth one is the binary data. So in the columns that contains binary data, yes or no, we transform the data into 0 and 1. And the last one and the most interesting one, I will tell later. Now here is a quick question. So these 2 people, so can you guess who will more likely to place deposit? Is it Jack? Jack is a 50-year-old self-employed divorce designer. Or Tom. Tom is a 20-year-old single university student. If you don't know the answer, don't worry. The visualization part will show you the answer. So in the visualization part, instead of using the number of people, I find it's easier to compare the conversion rate. That is, I use the number of the yes client divided by the total client, the number of total client. And if you look at the pie chart, we can see that of all the clients, the married people have a higher conversion rate than single and divorced people. And if you look at the conversion rate by age and the marital status, and you can see that the young single people have a conversion rate of 0.4. And also the divorced people in their age between 50 and 60 only have the conversion rate 0.02. So remember the 2 people I mentioned just now, a 20-year-old university student that belongs to this area. So he has a conversion rate of 0.4, and Jack, the divorced self-employed designer, has a conversion rate of 0.02. So we can say that Tom is more likely to place the deposit than Jack. And also, if you look at the conversion rate by jobs, we can see that the students group and the retired people have higher conversion rate than other job groups. So for the bank, they are the key client that we can organize some marketing campaigns targeted to these 2 groups. And in the next part, from the campaign data, we can find the insight is if a client has been contacted over 12 times or over 33 minutes, then the client is less likely to subscribe a term deposit. So the charts and the dashboards summarize the profiles of our existing client and the client with simple characteristics. So how do we deal with our future clients or the clients with complex features? So it's time to build an AI model. So before building the model, you still remember the till later part in the data pre-processing? Now let me show you. So the last data pre-processing problem is we need to deal with the imbalanced data. So actually, we need to deal with the imbalanced data because as you can see, the yes client is only account for 11% of the data set, and the majority of the client will not deposit. So if we train a model with the original data set, so it may get biased. So that may cause the result not reliable. So we use the technique called SMOT to make the imbalanced data balanced. So if we explain it in a simple word, SMOT can add duplicate records of the minority class, but do not add any new information to the model. For example, if you look at the picture here, we have an imbalanced data, cats and dogs. And if we want to use SMOT to make it balance, here is the oversampling technique. We duplicate some data here and make the data balanced. And after using the SMOT method, you can see that the data is balanced. And now let's welcome Yan to introduce the random forest model.
Okay, random forest is an upgraded version of decision tree. The random output result of the forest is determined by voting. If most of the decision tree test data is one result, then we think it is that result. Let's take a training data set composed of various fruits as an example. Random forest classifier divides this data set into subsets. These subsets are assigned to each decision tree in the random forest system. Each decision tree will produce its specific output. For example, the prediction for tree 1 and tree 2 is apple. Another decision tree N has predicted the banana as the result. The random forest classifier collects the majority vote to provide the final prediction. Most decision trees choose apple as their prediction. This makes the classifier choose apple as the final prediction. Next, please welcome Richard to share other model.
And the other model we use in this project is called K-nearest neighbors. So it's a model works by finding the distance between an object and all examples. For example, if you look at the picture on the right side, here we have an object. We want to know it is an apple or a pear. Then we set the parameter K, choose its K closest neighbors. So for example, if we set K as 3, then it will choose its 3 nearest neighbors. And as you can see, if we choose K at 3, there's 1 apple and 2 pear, and the object will be labeled as pear. So here's the basic information of the models. And then we train our model and to calculate the accuracy of the model. And the models we use are decision trees, random forest, and KNN. And from the result calculated, we can see that the accuracy of the decision tree model is 83.1%, and for the random forest is 87.4%, and for the KNN model is 0.1%. And also we use model tuning to find the best number of KNN neighbors, and we found that if we choose 18 neighbors, and the model have the best result, which is 0.906. So here are some key takeaways for today from the exploratory analysis in the data set. We know that young people, especially aged between 20 to 30, and students, as well as retired people or people who aged over 60, our key client, are more likely to place a term deposit. So our suggestion is we focus on those two groups and create campaigns for each of them. And another insight is that we found if a client has been contacted for over 12 times or over 33 minutes, then the client is less likely to subscribe a term deposit. So our suggestion is the call center staff can use these key findings as a guidance to screen the client and improve their efficiency. And the last takeaway is AI models provide an accurate and time-saving method to predict the target client. Then we can use these as to arrange some marketing campaigns, and the marketing campaigns can be tailored to certain group of clients. Okay, that's our presentation. Thank you.
So thank you, team Dataemon. I can definitely tell from your slides that from the presentation that I don't follow into this marketing campaign category. I'm not either in the 20s or the retired. So thank you very much for that. And I'm just wondering to say, yeah, Sally actually got a question over here. So question to you guys. So about like the cleansing and the pre-processing of your data. So how do you know that the duplicated values you dropped are the actual duplications rather than a client deposit multiple times? How do you decide around those dupes? I think at a very early stage of your presentation, you mentioned that you've done some kind of like a data cleansing and you dropped some duplications. Yeah.
Yeah. Yeah, because we set select some duplicate values from the data set, and we found that actually all these records are the same in all columns. So we found that's a duplicate. So if a client deposits multiple times, then maybe at least one attribute may be different. So if the data in all the columns are the same, so we can define it as a duplicate.
Cool. And I've got another question. So what factors lead you to choose the AI model? Can you explain?
Okay. Yeah, I can share my screen again. Yeah, can you see my screen?
No.
Let me share it again. Yeah, the model selection here, we do some research online, and we found that here's we want to do a classification problem. And for the classification and to do the classification problem, here are some models suitable for this problem. So like KNN, decision trees, logistic regression. So we choose some of them to build the model. Yeah.
And one last question from Jay is, does your data modeling only take the conversion rate, for example, like term deposit account openings into account, or the size of the term deposit? So for example, like the value of the term deposit, or another way to put it, does your data modeling only take the conversion rate into account or the size of the term deposit? If the client is looking for the latter, can this data modeling take the term deposit size into account as well?
Yeah, in our analysis, we just consider the client data and also the campaign data, because in our data set we have no information about the balance of the bank account of the client. So we will not do the detailed analysis about the balance of the bank account. Yeah.
Cool. I think that's probably all the questions that we can take just for now. I'm conscious of time. We are definitely going to run over, and hope everyone can still stay on this showcase, spend a few more minutes of your time. And thanks very much for Dataemon and Team Dataemon. And then I'll try to see if I can invite our next team to the stage and give their presentation. So this time we have Team QTF. Just checking to see how Team QTF is doing. Do you have any technical issues or anything over there? Hello? I think there's another team member, Ivan or George, Ivan. Okay, you're lining up. It's a big team. I can see about 5, 6 on stage. Yeah.
People now, and
awesome.
We will let Wendy to begin our presentation.
Awesome. Let's start.
Yeah. Good evening, everyone. Thanks for attending our presentation. We are QTF Solution teams. I'm Wendy, and my teammates are Ivan, Sylvia, George, Pi, Christina. Today, we are going to talk about the traffic accident in Queensland. Next, please. Today's session will be divided into following sections: background and motivation, use cases and questionnaires, exploratory data analysis, data visualization, machine learning, and summary. Next, please.
I'm sorry to pause you there. Is it possible for someone to share the screen? Because currently, I don't think we can see the screen.
I can see the screen.
Sorry about that. I'm now sharing the screen now.
Yeah, you might want to stay there. Cool.
Sorry.
This is the content. And next, the background and motivation. And when you can.
Okay. So I'll provide some background information about our project. The number of deaths on the world road remain unacceptably high. with an estimated about 1.35 million people died every year. That is, one person will die every 25 seconds. Also, the traffic accident is one of the leader killers of children between age 5 to 16, which shows a need of improving road safety. So the Victoria Road Safety Strategy 2021 and 2030 commits to the ambitious target of eliminating deaths from our road by 2050. The first step of the target is halving the number of deaths by 2030. Next, please. So how to deal with this serious problem? The first and most important step is to identify which factor has a significant impact on the severity level. That leads to our goal, evaluating all factors such as vehicle condition, weather condition, and road condition to identify which factor lead to high severity level in the traffic accidents. Then we can control those, the last one. So we can control those factors to reduce the crash severity and or even eliminate deaths from our road. Next, please. There are several use cases and personas. For example, police officers can use our systems to set the road speed limit and control traffic flow. The road designers can plan urban road with safe system approach. So human error will not be punished by the death or serious injury. The everyday driver can be trained more efficiently to become a better driver, and also the mobility service provider, such as Uber driver, can use our systems to adjust the fee based on hazard conditions. And of course, data is the driving for the machine learning. So I'll pass to Pi and Christina to provide more information about the data we used in our project.
Hi. In data exploration part, we have 5 small tables, and the first table is restraint helmet use. And in this table, it contains information about the relationship between crash severity and restraint helmet use, and changes among different genders and age groups as the year passes. Intuitively, the relationship between fatality and the percentage helmet use in populations is in positive correlation. Next page, please. And the second table is about the vehicle involvement. And in this table, it contains information about the relationship between crash severity and different types of vehicles, such as motorcycle, truck, and bus in accident as year passes. Intuitively, involving motorcycle causes more fatalities than other type of vehicles. Next page, please. The third table is about alcohol speed fatigue defect. This table contains information about the relationship between crash severity and different types of problems, such as drunk driving, fatigue driving, defective vehicle, and speeding as the years passes. And intuitively, the drunk driving causes the most traffic accidents in all 4 problems. And Christina will talk about the remaining 2 small tables. Thank you.
Thanks, Pi. So in my part, there are 2 tables of the exploration. The first table is the driver involvement. We can see from the line chart that crashes cause fatality remains the lowest and the most stable among the last 20 years. And the data of property damage only are the highest during the first decade, but are not collected after 2010. Crashes involved with hospitalized causes surpassed medically treated causes and also the #1 causes. All the crashes plummeted after 2020 because of the COVID-19. Next page, please. The next table is the root causes. We can see from the table, the age group in 17 to 24 generates the most causes in each police region and each severity. And also this age group has the highest ratio of the fatality. That's on my part. Let me pass to George to introduce the visualization of this data set. Thanks.
Okay, thanks for Christina. And my part is the main table of the data visualization. So which include a relationship between the several conditions with different level severity from 2001 to 2021. And the topic we try to analyze is the traffic accidents in each suburbs and the trend of the total number of traffic accidents happened and which day of the week has the most case and when. And the result we find is the traffic accidents are more likely happen on Friday during 3 to 5 p.m. And faster speed limit, fast speed lead to more dangerous crash severity. And the speed limit of the 60 has the highest case number. Next, please. And this is the dashboard I generate. So the first part is the filter. And the second is the casualty number. I use the scorecard. And the third is the Queensland map. And the fourth is the time. I use the heat map to the month and the days of week. And the time I use the bar chart. And the fifth is the conditions or speed limit is used the pie chart and other conditions is used the bar chart. And the next slide, I'm gonna show the demo how we can use the dashboard. Next, please. And have a look. Okay, anyone here?
I don't think I can hear what's in the background.
You can't hear the video, yeah?
I don't think I can. Can anyone else hear? No, probably not.
Just I think George, can you try to share your video here because my computer is having a problem on permission.
Oh, it's fine, just share and I will just talk here.
Okay.
Or otherwise you can actually just talk through what's on the video. And then it's just walk us through. Yeah. Should be all good.
George, do you still need to talk about the visualization?
Yes, you just show the video and I can just talk.
Okay, there you go.
I can't see any screen now.
Oh. Sorry about that. Just sorry about the technical difficulties. Now we'll continue our presentation.
Okay, so in this dashboard, did you play? Okay, so as you can see the map, we can just collect the map, and then you can see the information of the passcode, suburb, and the LG, and the custody total number. And you also can select, sorry, I don't think the video is. Yeah, and also we can just use the passcode to select which passcode we want to know. And So you can see we also can use the server to select which server you want to choose. So for example, we go to the Brisbane city. So you can just click, and actually this all dashboard number, all the value they are connected together. And also in the asset over time, you can select specific value you want to know. Like for example, the high list number, you can see it's on the 5-day main, and all information are changed together. And also, you can just select the fixed date, like Friday, or you want to know the month, like December. And also you can just select the year you want to get the information, like if you want to only know the 3 years, so you can just select the select bar. And also in the crash time, you can just select the time, like 3 p.m. And most of the crash is happen on the weekdays. And also, like when you want to know, like 12 a.m., almost the cash crash on the Saturday and the Sunday. And also in the speed limit, you can just select which speed you want to know, like 50 or the 60 or the 110. And also the conditions, if you want to know only the one condition, you can just select and you can get what's the situation in the Queensland. And also if you want to know combination of the situation, so you can just select and you can see all the information here. And as you can see, the car crash is far from the city. Okay, and this is my part of the dashboard, and I will pass to the Sylvia, sorry.
Thank you, George. So now it's my part for the data visualization of drivers' information. So the background of this part is it includes two tables. The first is the driver's demographics, and the second is alcohol, speed, fatigue, and detect. The analyzed topic include which gender and age group plays a dominant role in all crashes, which license type accounts for the majority of all crashes, and which traffic offense has greater impact on each crash severity type. The interpreted results, so we get from these tables are male drivers aged between 24 and 59 years old plays a dominant role in all crashes, and the full licensed drivers account for the majority of all crashes in the Queensland region. And the crash related to traffic offense take a small part of all total crashes. And the crashes related to traffic offense has a higher fatality and hospitalization rate. The next page, please. So here's a dashboard I created, just as the one that George presented for the main table. So it includes the first part is the filter, and the second part is driver's demographics, which is a tornado chart. And the third part is the license type and crash severity, which is a bar chart. And the fourth type is a traffic offense on crash severity, which is a donut chart, 6 donut charts. And the last part is percentage of count of causalities over crash year, which is a bar chart. Next page, please. No sound, right?
Can you hear us sound now?
I don't think I can.
Yeah, but I can do it. I can do it at the same time. Can you make it full screen, please?
Yes. Yes, please. Here we go.
Okay, so here's the dashboard demonstrating the driver's information, including their age, gender, and license type, and the traffic offense, such as drink and speed driving in the past 20 years in all crashes police region in Queensland. The first row shows the filters including the crash year, crash region, and a reset filter button. Now I'm gonna choose year up to 2009 and in Brisbane for the demonstration. So if you look at the buffer chart, it's pretty straightforward that the male driver aged between 25 to 59 plays a dominant part in all crashes. As for the license type, the bar chart shows the full license type is a primary license type for collisions. If you look at the two tips for each license type, you can see that no matter what the license type is, it all results mostly in hospitalization and followed by medical treatment. So the third area for the driver's information is about the traffic offense. So 6 donut chart shows the percentage of different types of traffic offense from left to right in descending order. And the color shows the severity of the crashes. So the darker the color is, the severe the crashes are. Normal, aka no offense, accounts for the largest amount for crashes, where in offense, drunk driving has the largest causalities. We can see that the fatality rate increases if the offense is mixed. That is to say, if the driver is drunk and speed driving at the same time, it's very likely that the crashes are fatal. So I'm reset all filters for the last part. So the last part shows some seasonality of the crashes, which indicates that in 2009 is when the crashes happen most frequently. So here's all my presentation for the driver's information dashboard. Thanks for watching. I will pass to Ivan for the next part. Thank you.
Next one, we will talk about the machine learning models we have used to select to analyze the Queensland traffic accidents. We have in this time we have selected the decision tree classifier. It is a simple supervised learning machine learning models and a developed set of rules to make classifications. The basic theory of the decision tree classifier is an internal node represent the features, and branch represents the decision rule, and each leaf node represents the outcome. And it will help the users to understand the major factors cause high severity of traffic accidents. The benefit of using the decision tree classifier is that the first is it requires less effort for data preparation during data pre-processing. And the second is to easy to handle the missing values and faulty values in a data set. That even kind of some errors in the data, you won't have affect the outcome, and even the performance of the decision tree classifier, and which these two major benefits will help the users to easy to understand the outcomes of the decision tree model. And next, I will going to show the demo that represents the decision models of analyzing the traffic accidents. Here's the decision tree model we have developed. As you can see, when the crash speed limit is greater than 65 and less than 80, most cases are classified as hospitalization and even fatal when there is not a multi-vehicle crash. And when the crash speed limit is less than 65 and is not having very quite serious cases that mostly classified on medical treatment and even the minor injuries. However, there's one special cases that when the unit part crashes not that much, even which will be classified as fatal, as these traffic accidents will lead to a pedestrian being affected by the traffic accident that will causing more serious cases that will lead to fatal. Here's the decision tree model we have developed. In the summary of the project, we have provided some suggestions for the government that they can improve the speed limit on special locations to reduce the traffic accidents. The second is they can add more traffic control authorities in certain suburbs to save more lives after being impacted by traffic accidents. And the third one is to improve the road design to avoid multi-vehicle crash. If the Queensland government has successfully to handle all the traffic accidents happens in Queensland, we believe that in the future they will provide safe road conditions for the drivers and a safe environment for pedestrians, and even achieve the final goal, which they will create a safe and beautiful communities for Queensland. Here's the end of the presentation, and thank you very much, and hope you can enjoy it.
Cool. Thanks very much, Team QTF Solution. Just wondering if anyone has any sort of like questions for the team.
Thank you.
Yeah, Chris. So Yeah, so the first question is, what's your average accuracy for your model? And do you have any sort of like future plans to improve the accuracy of your model? So that's the first question. And second one is, do you have any plans or actions to avoid overfitting of your model?
The average accuracy we have been tested for using a decision tree by changing several parameters that we had we had tried to use the Gini index and the entropy as for testing. The major accuracy it can result in when we're going to select the entropy for training the data. We're providing high accuracy that is about 85%, and when using Gini index, it will be around 82%. And overall, it is mainly high because entropy will have more punishment on the effective of the data. So in order to having a high accuracy, we decide to use the entropy as the criterion of the decision tree. In order to if we want to do the further improvement on the decision tree model, we can set the minimum sample lists and even the max depth in order to control the tree, in order to control the nodes being expanded and even being grown. So such as like when we set the minimum sample lift to 1,000, we will kind to restrict that the characteristic will be split. Only the samples is over 1,000. It will the settings we're trying to avoid. We're trying to avoid some not quite useful characteristic being identified or speaking on the decision tree. That is quite useful when we're trying to train the data. In order to avoid overfittings, we still need to test the max depth. During the time we're trying to testing all the decision tree, I had tried to set the max depth from 1 to 10. And it's quite easy to see that when the max depth is equal to 3, around 3 to 4, the overfitting issues is the least overfitting issues. Yeah, but anyway, if we still want to reduce the overfitting issues, we still need to have more tests on the decision tree. And also the decision tree models have one kind of disadvantages that they will very easy to use to have overfitting when implemented what kind of data set have been implemented into the models. At that time that I'm trying to use the random forest classifier and even the SG boost to handle different cases of data sets. This is all the answers for Grace. And now for Siying, and I saw her question is, have you considered any other models than decision tree classifier? Absolutely. The decision tree model is the baseline model we're trying to do the test. And as I just said before, and I can use if we want to make the more perfect models for identifying the characteristics of which affect the different severity of Queensland traffic accidents, we can use the random forest classifier and even the SG boost. And one of my teammates used to introduce another method, which is the gradient boost regressor. However, this is we are providing high accuracy. However, it is another different approach of the machine learning. Yep. This is all the answers. Thank you.
Oh, thanks very much for your answer, Team QTF. And one thing I can add over here for Siying is, I think in the insurance pricing, car crashes modeling, for example, frequency severity, those are the bread and butter. So we've done that day in, day out, and that's so if you try to get some more sort of like a feedback from Siying, that'll be really awesome to improve the project with the Queensland traffic. Cool, that's all we have here for all the presentation. I'll just open the floor because I'm also conscious of the time. We really run over time for quite quite heavily. Anyone, I'll just open the floor. Anyone wants to come to the stage or want to even type some message or ask some more questions, please feel to do so. Has anyone volunteered? No? Cool. Then that's it. I think that will be the end of our session today, our showcase today. And I can definitely see that our students actually have done quite a lot, very extensive analysis into it. And everyone's sort of like every team is sort of like getting overtime because even though we're restricting that to about 15 minutes, but I think it's just not enough time for us to show the work, the great work they have done. Jay actually asked, I said, what are the main tools everyone uses to get this data modeling? Like Stella mentioned, so SQL, Python, Tableau, they are the sort of like the main tools we use for this course. And I also believe they are the main tools for all the popular tools for currently on the job market, or every data professionals are actually using. If no other questions, I'll just end here. And thank you very much for joining our session today, and hope you enjoyed the night, and we'll see you next time. Thank you.